Welcome back to science class on work and energy. Work and the types of energies you can see here: thermal energy, electrical energy, wind energy, solar energy, work and energy. Concept of work, units of work in SI and CGS, and define 1 joule. So we'll discuss now here. If you see this picture, the walking, playing, swimming, studying, this all comes under the examples of work. So what is work? Define work. Take point A and point B on a table, mark it as a straight line, and keep a duster, and then apply the force F to move from one place to another place, and we call it as a displacement here. So what is work? Work is said to be done whenever a force acts on an object and it displays in the direction of applied force is known as work. How work, force and displacement are related to each other? We know that work is nothing but the force applied into displacement. So here work is W, force is F, and displacement is S. W is equal to F into S. Write MKS and CGS units of work if work is equal to force into displacement. MKS, joules, is equal to Newton into meter. So Newton meter. So joule is equal to Newton meter. 1 joule is equal to 1 Newton 1 meter. So define 1 joule. Work is equal to force into displacement. The amount of work done when a force applied. What is that? The amount of work done when a force of 1 Newton is applied or acts on an object to displace it through a distance of 1 meter along its own direction is said to be 1 joule. Very simple. The amount of work done when a force of 1 Newton acts on an object to displace it through a distance of 1 meter along its own direction is called 1 joule. In CGS, instead of joule or ERG and newtons, dyne, and meters, centimeters. So CGS units of work is org is equal to dyne centimeter. 1 org is equal to 1 dyne into 1 centimeter. So define 1 org, classroom activity this is. So 1 dyne instead of 1 Newton and 1 centimeter instead of 1 meter. Same definition. And here instead of 1 joule, we'll write as 1 org. An example, the force of 5 Newton acts on an object and object is displaced at a distance of 2 meters in the direction of force. Find the work done. Work is equal to force into displacement. Is it right? This is an object. Force applied is 5 newtons and at a distance of 2 meters it is traveled. Object displaced by 2 meters. Then given data, force is equal to 5 newtons, displacement is equal to 2 meters, and work done is equal to force into distance. So that equal to 5 into 2. That equal to 10 joules. The work done in a given condition is 10 joules. Does energy and work have same units? Yes. And at the same time, how many types of work is there? First, positive work, negative work, and neutral work. What is positive work? What is negative work? And what is neutral work? First question, does energy and work has same units? Yes, units. For work, SI units, joules, that is Newton meter, and CGS units, erg, that is centimeter or dyne centimeter. Relation between SI and CGS units of energy. Joule is equal to 1 joule is equal to 1 Newton meter, and 1 Newton is equal to 10 power 5 dynes, and 1 meter is equal to 100 centimeters. So 10 power 5 dyne into 10 square centimeter. So 10 power 7 dyne centimeter. 1 joule is equal to 10 power 7, or how does an angle between the force applied and the displacement of an object affect the nature of the work done? Product of the given factors are of two types. One is dot product and another is cross product. A dot product is a cos product, whereas a cross product is a sine product. Cos and sine are angles here. For example, a dot product A into B, A dot B is equal to AB cos theta, whereas a cross product A cross B is AB sine theta. A and B are the given vectors and theta is the angle between the vector A and B. For example, A vector in this direction and B vector in this direction. Then angle is theta. When cos and sine are the trigonometric ratios, here if you see this where cos and sine are the trigonometric ratios, some angle is given here. Thus, work is equal to Fs, work is equal to Fs cos theta in case 1. When F and S are in the same direction, that is F parallel to S and theta is 0 degrees. So this is nothing but parallel. You can see this is F and whereas S, both are in single line, then theta is 0. Sine F parallel to S, then sine theta, means cos theta is 0 here. Fs cos theta, cos 0, so F cos 0 is 1, then W is equal to Fs. This is case 1. Thus work done is positive. Case 2. When force F and displacement is S are in opposite direction. Here in the same direction, that is positive, opposite direction, that is negative. Theta is 180 degrees. So here you can see launching of rocket. Whenever the thrust force here, the force applied is downward and the object is moving upward. Displacement upward and force downward according to Newton's third law. It's moving upward and the displacement is in this direction. You can see here angle is 180 degrees. So W is equal to Fs cos theta. W is equal to Fs cos theta, that is cos 180. 180 degrees is also 1 but minus 1 here. Fs cos 180 is minus 1 and W is equal to Fs minus Fs, that is. Thus work done is negative. Case 3. When force F and displacement S are normal to each other, that is theta is equal to 90 degrees. If you see, normal means perpendicular to each other. If you see here, natural satellite of Earth is Moon, which is moving in this direction. The force, this is displacement, and this is force, gravitational force towards Earth. radius. This is force which is acting, and this is displacement. Here, if you see, the angle is always 90 degrees. So, thus W is equal to Fs cos theta. Theta is 90 degrees. Cos 90 is 0. So, Fs into cos 90. Cos 90 is 0. Simply Fw is equal to 0. Fs into 0 is 0. Work is 0. Thus, work done is neutral or no work is done when the force applied and the displacement are normal to each other. Whenever 90 degrees is there, force and displacements are each mutually perpendicular to each, then the work done is 0. Numericals based on the neutral work, the types of energies. First, a mass of 10 kgs at a point A on the table, it moves toward the point B. If the line joining A and B is horizontal, what is the work done on the object by the gravitational force? Explain your answer. We know that gravitational force acts always downward. So here is the table and here object A, and it has to move to point B, and the work done by the gravitational force. We are not calculating the work done by the external force, work done by the gravitational force. We have to find. So mass M is equal to 10 kg. Displacement AB is horizontal. To find work done on the object by the gravitational force. This is not work done by the object, work done on the object. By the which force? Gravitational force. Okay, gravitational force in the sense earth force that always acts towards down. And here, formula to find work done is W is equal to Fs into cos 90 degrees. Why 90? The angle is 90 degrees between the gravitational force and displacement. Solution: for a force of gravitation acts always downwards. So here it is force of gravity, and this is displacement. Angle is 90 degrees. The angle between the force and the displacement is 90. Then the work done is equal to Fs cos 90 degrees. As cos 90 is 0, Fs into 0 is 0. So work done is 0 joules. So no work done by the gravitational force. Thus work done is 0. Second problem. A pair of bullocks exerts a force of 140 newtons on a plow. The field being plowed is 15 meters long. How much work is done in the plowing the length of the field? So here, with the help of bullocks, we are plowing the earth, what we call field of 15 meters long. You can see here, the force applied is 140 newtons on plow, and displacement is 15 meters long. Then how much work is done on plow in plowing in the length of the field? So here we have to calculate in the length of the field. Work done is equal to how much? Work done is equal to F into S. Work done is equal to F into S, that is 440 into 15, 2100 joules. That's it. Along the same direction, so it is positive. Thus the work done in the plowing the field is 2100 joules. Types of energies. You know that there are basically two types: kinetic energy and potential energy. Define energy. It is the capacity to do work. It is nothing but energy. So here, heat energy and wind energy and sound energy and electrical energy and light energy. If you see, one more energy is also there, tidal energy. So these are the types of energies: heat energy, wind energy, sound energy, electrical energy, light energy, tidal energy, solar energy. Okay, very good. Mechanical energy. What are these two mechanical energies? First one is kinetic energy and another is potential energy. What is kinetic energy? You can see the cheetah in motion now. The energy possessed by the virtue of its motion. When a body is in motion, the energy which is possessed by this motion moving body is kinetic energy here. The energy possessed by virtue of its motion. Whereas potential energy is rest. The man is at rest and certain height. The energy possessed by virtue of its position or shape is kinetic energy. Potential energy we can say here. Work done in lifting an object. Work done against the gravity is independent of path followed by the object. Derive an expression for the work done in lifting an object of mass m to a height h. So this is, let's consider an object of mass m and then it is lifting up of height h. So this is mass. So slowly lift up and then measure it, the height from point A and to point B of its height is h. Okay. So what we have to find here, work done in lifting an object of mass m from point A to point B of a height h. So thus work done in lifting the object of mass m to a height h is work done is equal to force into displacement, as we know that force F and displacement is S. So force is nothing but mass into acceleration and displacement is nothing but height mah. So here as we know that acceleration is nothing but gravity force, acceleration due to gravity. So we can write it as W is equal to mgh. Acceleration due to gravity, A is nothing but also G. So if you observe, the body is moving downward or upward. Thus the work done is given by the equation W is equal to mgh. Always remember, where W is equal to work done, m is mass of the object, G is acceleration due to gravity, and h is height to which the object is raised. This work done is stored in the form of gravitational potential energy. So we call it as potential energy. Solve the problem based on it. A porter lifts a luggage of 15 kg from the ground and puts it on his head of 1.5 meters above the ground. Calculate the work done by him on the luggage if the gravitational force is acceleration due to gravity is 10 meter per second square. Mass of luggage is m is equal to 15 kg. Displacement is 1.5 meters. Find work done is equal to question mark F is equal to m into G, W is equal to Fs, that equal to m into G is nothing but 15 kg into 10, 150 newtons, whereas W is equal to F into S, 150 into S is 1.5 meters. So this is 225 joules. Thus, the work done is 225 joules. So next concept will continue in the session part 2.